right, so let's go ahead and get started. We might have a few people still trickle in, but thank you all for coming to the second Tech Talk of this academic year. And I'm very delighted to finally get you guys, Liz McCormack and Doug Blank and Mark Matlin, to talk to us about a TIDES project that they've had going on. This is a grant-funded project to incorporate computational studies, if you will, or sort of information science skills into the physics curriculum. And I'll let them tell you the rest.
Good afternoon, everybody. We're happy to be here to tell you about this project. And although we had a particular context, I think some of what we learned and the experience we gained could be of use and of interest to a wider audience. We have a three-man show here. One lady, two-man show. I'm going to give an overview of the actual project and what we accomplished. We just finished year 3, and we have one more year to go. But the gentlemen are going to give you some specific examples of the types of learning modules that we developed based on this model of a web-based executable notebook that's multimedia and in some ways lends itself very well to the goals of this project. So if you'll withstand me just saying a few things based on this slide. This slide was something we prepared to present at our latest annual meeting. It's a kind of summary of the project. So our project was to enhance the computational skills of our students here at Bryn Mawr, and this project was in the context of the physical and natural sciences. And we had this idea, and this is what this graphic over here is supposed to represent, that we wanted to try out a concept that wouldn't require hiring more faculty, mounting more courses, but instead develop modules that could be used in the so-called blended format in conjunction with our curriculum. And so we started with a project focusing on developing these modules to be used with the physics major, but they could be expanded to chemistry, geology, biology, and things like that. So the other context besides this notion of enhancing skills development for students in computation was to enhance the capacity of faculty to teach in more inclusive ways. TIDE stands for Teaching to Increase the Diversity and Equity in STEM. And so with Jen's help and faculty from across the campus, we fashioned and put together a workshop that we've run now several different formats, 3 to 4 hours or 70 minutes, that involves informing faculty and other participants about the scholarship on what creates inclusive learning environments and inclusive learning assignments. So some background, and then a set of case studies that provide a kind of interactive way for the participants to try to apply what they've just heard about in that introduction to what the scholarship tells us. And then finally a resource list and a survey of faculty, which we wanted to collect some information for our grantors. And so I would say the major outputs from the project have been 14 computational learning modules that Mark principally really authored, and Doug supported by helping us put up a server that supports their execution, which they'll tell you about, this faculty workshop packet, and essentially testing this kind of blended learning model for skills development that's in tandem with the course. So you'll notice typically, you've got your 4 years of college, you might take a computational methods course, but what we did was make these modules, and now we had this idea that they would be taken consecutively during the 4 years, and then an e-portfolio could be kept by students demonstrating their computational skills development. So we have IRB approval to do pre and post student surveys to understand whether students' skills are developing, but also their attitudes about their identities in who does computer science and who has these computational skills, and their attitudes about their role in their major. as well as surveys from faculty and others who have taken the workshop on inclusive teaching. So our year 3 update was not only can you, with these notebooks, teach computation skills, you can put in things like journaling, assignments to research folks in the field of computational science, whether it be in physics or something else, decoding, how to use office hours, the adaptability of executable notebooks for all the different media allow you to kind of totally integrate some of these best practices in the actual computational assignments. And I think Mark's going to show you an example of that. And the other thing I wanted to mention is Doug set up a GitHub repository where we're sharing all our materials and where folks can actually contribute to the modules if they want. One of the things that the funders of TIDES, which is AAC&U, their PCAL or science initiative, funded by the Helmsley Fund, they really wanted us to measure project impact in terms of the number of students we touched. So this 15,000 students represents all the students that anyone who's used our materials in some may have affected by the grant. So over the last 3 years. So to give you a flavor, we've done 3 faculty retreats. We've offered the faculty workshop materials 4 times. 6 different institutions have requested the modules. 6 different institutions have requested the workshop packets. We've done some collaboration with colleagues in making presentations. These are other colleges involved in the TIDES project. And I think collectively we've all made about 7 presentations on this work. So it's been a really interesting project. We're still working on disseminating what we've learned to other disciplines. We were hoping there might be some folks here who are interested in helping us do that. And if they're not here, we'll try to wrangle them in May when we have another conference. But we're also, and we're looking forward to a Jupiter Day conference, which will happen in May in conjunction with the Blended Learning Conference, as a final kind of push to talk about how these notebooks can be used to enhance the effectiveness of teaching skills like this, but also enhance the learning experience in what we hope are pretty universal, equitable ways of teaching. So I believe Doug's going to speak first, show you some examples of notebooks that include how he's used them in his own teaching, before Mark will show you some specific examples from this project.
Great.
Any questions on the overall scope?
So I'm going to talk a little bit about this idea of a computational notebook. And this might be, it may sound really odd, but you probably have an intuitive idea of what it is already. Have any of you ever used Mathematica? Okay, so many of you have seen that. So this idea is sort of like that, sort of like a Mathematica idea, but it's language independent. So that means that you don't have to type in some Wolfram language. You can type in better known languages like Java or Python or many other languages, including all the languages we teach at Bryn Mawr Computer Science. So I'm going to talk a little bit about this technology and how it fulfills our goals in TIDES, both with the cultural sensitivity and bringing computation into physics specifically. But before I did that, I want to say a little bit about the philosophy of it and why I think this is a really interesting project for liberal arts colleges in general, regardless of the discipline. And maybe I can just take a quick poll here to see where are you all coming from? What departments or interests?
Maybe
Physics?
lilac stone.
Lilac STEM? Okay. Say that louder. STEM, math? STEM? Okay. So it could this could be useful from anywhere from Russian to STEM, mathematics, and economics, and all of those things in between. It really is, to me, it's about storytelling. So that's what I want to talk about is, and we all see this tool being used in different ways, but I see it as a fundamental way of telling stories, both for the faculty to tell stories to the students, but also for students to tell stories back to us. And that's part of the reason why I think it fits in very nicely with our cultural sensitivity aspect of the project. The students are taking physics and computation and weaving together their own stories and telling us. So how does this work? Well, I have a little notebook here that has some stuff in it, but maybe I'll just quickly show you what a new notebook looks like. So notebooks come in different flavors, different languages, and when you create one of these, you need to pick what language, what computational language you're going to use. And you start out with a blank screen. And this is something that you can, like a blank document, you can start to put together pieces in order to tell your story. Part of this could be computational. So x equals 1, print x raised to the 5th power, for example.
Be very interesting.
No, that's not very interesting. So we can go back up to that cell and change that to be 2. X is now 2, print x to the 5th power. 32. Okay, that's a little bit more interesting. So you might use that, and of course you can write more and more complicated functions, and I'll show you some other examples, and Mark will too, about how this integrates with physics. But you can also use this to include text. So let's have a title here, and maybe a byline, and this is some text. Oh, and that's misspelling, so let's turn on the spell checker so we can see, you see that, make that a little bit bigger. So the idea is that you can include multimedia, videos. Mark's going to show some examples of these, and you can put them all together, including computation, graphics, graphs, dynamic things, including things that digital humanities people might be interested in. So let me just show you a couple more cells, and then I'll hand this over to Mark. This is what it looks like when it's rendered. So if I double click on a cell, you can see, I didn't show you that, I just wrote that, but if you shift enter, it now gets rendered like you would in HTML. In fact, what we're writing in is a simplified version of HTML called Markdown. So here you see italicized, and so a little asterisk makes that italicized. Here, this looks perhaps complicated. I've got bold and italics, strike through. Of course, when you're writing Word, you don't have to worry about that at all, but you do have to worry about this in this system. So it uses Markdown, which has a really nice parallelism with code. So you write in this source text, Markdown, and then you render it. And that's the same way with code. You write in the code and then you execute it. So there's a nice parallel between HTML and the form it takes and what you actually write. So I actually like that. So let me show you one. Mark's going to show you some equations, but here's Maxwell's equations. That's what it looks like. It's very beautiful. What you write actually looks more mathematical. So if you know LaTeX, if you're coming from that background where you have to write equations like that, then it knows LaTeX. So you can very easily write an equation, and this is the probability of getting k heads when flipping in coins. So that's one way, mathematicians think about code process, but computer scientists would actually turn that into a program that could then run. I did want to show you one really cool thing that incorporates data and turns it into a visualization that you can see right inside the notebook. So anything that happens on the web right now, you can just grab it and include it in your story. So that might be other maps or timelines or other things like that. So there's a Night Lab product called Story Map, and Oh, this is quite a bit big. Let me make this a little bit smaller so I can see it all on the screen here. So this is a story map included in a cell. And a story map is really a nice project that includes maps and timelines. And it's really easy to put together a story using these points in time and space. And you can put this together in lots of different ways to tell a particular kind of story. It doesn't have to be necessarily a history story, but it could use time and space in a really abstract way. And I think, I'll show one other little thing here to show that this is an extensible system, so you can take it and make it work in ways never dreamed of before. This is a project that Josh Shapiro and I developed for intro biology. So there's a course you can take on campus that's the introduction to biology and the introduction to computer science. You take that one course and it satisfies both the introductions. So we made up this language so students could do this basically on the first day of class. So they could do something, they could log into and write in the notebook. So this is a student project. That's supposed to be a ladybug, and she's written the program so the ladybug can go around and eat as much food as it can. And so we were talking about foraging, and we're talking about programming. So this is a really nice example that right from the get-go we're talking about biology and computer science in the course. What do you think? Can I make it? Almost. If she had a little bit more time. We did this in a week. So that was a week. It also has data. So this whole system was designed for data science, but we've taken it and we've put our liberal arts mark on it and really trying to sort of head it into a way that's really useful for digital humanities, computer science, STEM. And so I think with that, I'll turn this over to Mark.
I'm going to need to log in here to show some notebooks.
So I have to log me out, I suspect.
Oh, really? Okay. Doug didn't mention, but this, I don't think he mentioned explicitly, but this is a browser-based system, and you can run it either on your own computer, if you download the appropriate software package, or as a Bryn Mawr student or faculty or staff member, you could run this on our Athena server as well, which is basically kind of a small supercomputer. I have to spell my name right to log in. Sometimes I forget how I spell it.
So we have a supercomputer on campus, is what Mark was saying.
Right.
It's a small supercomputer.
It's getting bigger.
Yeah, exactly. It has a lot of nodes, and it has even more nodes. The HHMI grant just added a bunch of more nodes.
Well,
Yeah.
that's
It's got a lot.
just got a lot.
So here's an example of one of our modules. The first three modules just are teaching. We use the Python computing language for our project. The first three modules kind of walk the students through a sequence of exercises to learn Python and provide a lot of other supplementary resources. As Liz mentioned, one of the focuses of this project was to try to make computing more appealing to a broader cross-section of students. And so one way we tried to do that was to include these scientist profiles, brief profiles of people who either developed something in computer science or use computing in some way in their careers. And these were actually generated by students who took our pilot course in the spring of 2015. So we taught this course once, and the plan was just to do it that one time, get a lot of feedback from the students, and use that to improve these modules. And one of the things we asked the students to do was to find or develop these profiles of scientists. And we asked them specifically to find people who they found inspiring in some way in the field. And so we got a very nice, diverse set of profiles of people going back maybe to the mid-1900s who worked on early computers, like at the University of Pennsylvania, all the way up to present-day computer scientists, people doing robotic swarm research and things like that. So that was one of the kind of blended elements. Here's another new kind of element that I added to the most recent version of this module. There's another focus was kind of metacognition and getting students to think about their learning process and what might affect it, both adversely and positively. So here's a video on the concept of mindset, which you might have heard about. So this prompt asks the students to watch this video, which is embedded in the notebook, so they don't have to go anywhere to find this. It's right there. They can play the video. We'll see if it actually works. Yeah. So it's a TED Talk, TEDx. And then they're asked to comment on what they got out of the video and what takeaway they get from it.
Hard work, focus.
It's an interesting video if you have a chance to take a look. So here's another example as Doug showed. Maybe I'll expand this a bit. You can mix standard text with mathematical equations written in LaTeX and graphs. So this is just a figure that I got off the web and embedded in the notebook, but as Doug showed, you can also produce your own graphs. I think these were all, so here's some actual code. Often what I did was give students a chunk of code because at this point, this is the third module, so it's still early on in the sequence. People haven't mastered Python yet, so I would often give a chunk of code and then ask them to modify it in a certain way to achieve a particular desired goal, and normally there was a plot associated with it. In this case, I don't think there is. But again, you have this mixture of code and text. And so not only can the instructor explain the code and talk the students through it while they're looking at the code, and they can run it at the same time they're reading about it, but in the homework assignments, students would submit that in the form of these notebooks as well. They would run their code and then include their own analysis of what happened and their comments on how well it worked and did they get the results that they expected to. So that's, and each module had some exercises the students were assigned as homework sets. In the situation where they're not taking these as part of the course, but they're doing this extracurricularly, as Liz mentioned, we'll be asking them to submit an e-portfolio of their work on the modules. And so someone would grade these at some point. And Doug developed a nice scheme on this server that would let the students submit the notebooks to me. Then I could write comments in their homework notebooks, and then I would email them back to the students. So almost all of the interaction and work is happening in this format. Some other feedback that we got from the students during the semester we taught the course was that they thought it would be helpful to have some sort of quick questions that they had to answer along the way. And they wanted the answers to those in the notebook. So I called those breakpoints, which has a connection to computing. And so for every breakpoint, there's an answer at the end of the notebook, and they can check whether they understood that concept. So, we tried to make them as interactive as possible without actually having a person talking back to them as they were going through this notebook. Another example I wanted to show is here. So in addition to videos and images, there are other kinds of objects you can embed in these notebooks. I'm not sure how well you'll be able to hear this, but I wanted the students to it's not, sorry, wrong place. There we go. I wanted the students to analyze and modify some sound files, filter sound files. And so I was able to go on the web and just find a sound file player that someone had developed in Python that would run in these notebooks. And so the students can play the tone before and after they analyze and filter this sound. And so this is embedded directly in the notebook. I don't know if you could hear that, it's just a piano note. And then they filter out some of the frequencies and they get it sounds much more like a synthesizer or some kind of electronic device. And these are example of plots that were produced in the notebook using an add-on package to the Python programming language.
So each notebook is a file?
Each notebook is a file, an executable file.
And so you would have students email the file to you and you would have a system for collecting them?
Actually, Doug created a nicer system than that.
You can
yeah,
submit it if you want.
Right. Haven't done it for a while. Okay, so here's a button that says submit this notebook. They click on that. Yes, I want to submit the notebook. And then it gives me a drop-down menu of people on the system to whom the notebook can be submitted, and then they can specify what assignment it is, what course it's for. And that all goes to a directory on the server that then I can access the files in.
And then you mentioned the idea of student portfolios. Would
Yes.
they then would that be a folder on the server as well?
Exactly, yeah. Mm-hmm.
But they, no, I just to finish, so they could presumably, the idea would they would be able to access that throughout their careers.
Exactly.
Or wherever they happen to be.
Exactly, and in fact we weren't, I don't know if we got to this point, but our idea eventually would be that if they didn't put it on Athena, they might put it on GitHub or some publicly accessible site where it would exist forever. Athena may not live forever.
They could put it anywhere. It could be HTML, and part of the idea is that we're collecting it for them and helping them create their e-portfolio.
Mm-hmm.
So everything that they do in class becomes part of their portfolio.
So student submits this, you have the chance to grade it, offer them some feedback on
Mhm.
it. You've already put it in the e-portfolio. Are they able to then go back and update what's there in their e-portfolio? Who manages the e-portfolio?
They do.
contents? Okay.
They do, yeah. I mean, our vision was that they could use it for job applications, grad school applications, as evidence of what they had accomplished in programming.
So it's not static once they hit the submit button. The submit button just gives it to you, but then it lives on in their portfolio in a executable changeable.
Exactly. Right.
There was a question.
Yeah.
And you've kind of answered it with your reference to GitHub, but basically I was interested in how collaborative you could make these notebooks in terms of giving groups of students access to individual notebooks, for instance. And it sounds like actually, if not with the Athena server, then if you use a different collection point like GitHub, then access can be granulated.
It's a little bit more complicated than that. It's going to be the opposite, I think. GitHub is going to be one kind of collaboration, but the next version, so this is an ongoing project, the Jupyter project itself, and one thing that they want to make it is work more like Google Docs.
Okay.
So as you log in and another student could log in and you can see that each of you are editing it. If you think Google Docs, that's where we hope it's going to be in a year or so.
Who's developed Jupyter?
It is out of a grant from some of the same people that we have our money from, Helmsley and Mellon and National Science Foundation. It's centered out of Berkeley and another California school, Cal Poly.
San Luis Obispo?
Yeah.
And Liz mentioned Jupiter Day. This is an annual or more than annual conference that's offered under the auspices of this Jupiter group. And as Liz mentioned, we're going to be hosting one next May. I don't remember the exact
May
dates.
19th.
May 19th.
Mark your calendars. Friday.
We hope to invite a whole bunch of folks who are using these notebooks not only for computational skills development, but digital humanities, other fields, and talk about the notebooks themselves as a vehicle for inclusive teaching. So we hope to have a lot of examples show up.
Including anybody that wants to develop something between now and then.
There's plenty of room on the server.
It's a supercomputer.
And if any of the math science students are interested, we're running a boot camp on Python and the notebooks this semester and next semester. It's not too late to jump in and join us if you want to. We just started a couple of weeks ago.
If someone were interested in that, who should they contact?
Me.
Okay.
How did you all, I'm curious about the topics. You said you had created 14 modules. How did you sort of figure out what those topics were going to be, and how much would you say they are physics driven versus you could kind of take them and put them anywhere? If that makes sense.
Yeah, I kind of cheated. I found a wonderful, fantastic book on computational methods in physics and basically paralleled the development of that textbook more or less. The methods that the modules teach are not all that focused specifically on physics. Many of them have broader applications. And we were hoping to get from our colleagues in the other sciences examples of applications of those techniques that we might include in the modules. I wasn't that good about pursuing my colleagues for those examples, but that I think
This
will
year
be
we-
where we're going to go forward. Yeah.
So right now the examples are physics examples.
Physics examples,
But the
right.
techniques are more broadly used.
Right. And it would be easy enough to include other techniques that are more pertinent to other disciplines.
The other thing that may not have come through, maybe there's a pull down where you can show all the computing languages
Oh, yeah.
that the kernels run in this notebook format.
And these are only the ones that we have installed. That there are actually over 80 languages.
Oh, okay. I was thinking R, because R is a computing
Yeah.
language we use in biology. I don't know what you use in econ,
We use Stata, but R is quite common in
but
the field.
yeah, so they
There's-
have an R kernel that runs on this.
And there's a lot of development between Python and R. So there you can, in fact, any of these notebooks you can actually use multiple languages inside that, even though the notebook is really designed for Python, you can call other languages from inside. Wanna try it?
I have a question for you. So what's next? Like, what are you planning for the next year of the grant? What sort of directions do you see this going in the future? Are there places where you want to develop more modules, or?
Yeah, one of the requests we got from the students teaching the course was to do more with big data. But I'm not sure they knew what big data was, and
Yeah.
I'm not sure I know what big data is. So one goal might be to try to identify some kind of big data that might be of interest to students and develop a module on that. As well as we said, bring in applications from other fields. Am I forgetting anything?
No, and holding this conference.
Holding the conference.
Contributing, I think, to the conversation about inclusive teaching, universal design, and the way the notebooks can help you do that.
I actually used this in a college seminar course, and I'm very interested in seeing if we can get data to be part of the writing process. You know, right now it's such a separate process. We have quantitative issues, and then we have writing, and those are very separate. But wouldn't it be interesting if the college seminar could, or at least maybe some of them, incorporate data, and that you could write perhaps in something like a notebook and create a graph on the fly to help support your argument?
I have a
What was the general learning curve? So I mean, obviously the students are learning how to use the notebook while learning how to code, while learning whatever they're actually coding and things like that. So how much of the entry was difficult for the students?
Yeah, that's a very good question. Learning to use the notebooks, I think, was pretty straightforward for them because the interface is pretty simple. The coding was more of an issue. When we taught the full course, it was, a 14-week course, and we got through 13 or 14 modules, so it was basically one a week. Although we spent more than a week on the introductory modules where they're learning Python. We tried to do this in our introductory lab course last year, and we spent 4 or 5 weeks on just the introductory modules teaching Python, and the students were struggling. But I think a lot of that was because they are mainly freshmen and sophomores, whereas the students who took our course were sophomores, juniors, and seniors, and so they just had a little bit more mathematical maturity, and maybe they had done some programming previously. So it takes more than just a few weeks.
That's a good question. I think some of the anxiety from students comes from that very point. If you show people, it can, wow, can I learn all of that? Can I learn the programming and the graphics and the tech? So what I've done in the last couple of years in my intro to computer science is the first day of class, I tell students, bring your laptops. They do. I give them a password, and we write code on the very first day of class. So there's no trying to argue, oh, you'll be able to do it.
Right,
You do it. You've already done it. And
Yeah.
so then, like Mark said, then we learn and we continue to build on those skills, but try to break down those barriers right from the get-go.
I know of a faculty at Smith, trying to think of his name, blanking, but teaches statistics, and he has encountered that when he's doing R. He wants to teach the students R because it's something that they can take with them, but for many of them, they've never seen a command line before, and I think he's tried things like RStudio, but it's still that, oh my gosh, I'm trying to learn the statistic content and the sort of programming that I need to do this, and so it is very much a sort of spending as much time thinking about, okay, well, how do I get them up to speed with the programming as it is getting them up to speed with the content, right? You can't just go in and say, okay, well, we're going to use this software. He's figured that it actually takes scaffolding for all of it. And I would think something like this, though, might be helpful for his students because it would make it easier to switch between that visualization of what you've done and the actual code, which is, I think, one of the things that people find daunting with something like R, where you execute it and then you have to go back up and see what it is that you did, and kind of execute it again, and stuff like that. This I think would be helpful.
For me, I don't use PowerPoints anymore. I use this. So every single lecture that I do is something that they can download and run themselves. I do a lot of what we call live coding. So just start out in class with a blank slate, and we build up interactively in class with sort of the flipped classroom model. So in class, we do pair programming where students will work together. They start from nothing and work on a problem. And I think Mark has done something like that too.
What will you show us?
I don't remember where we did this, or whether it was something you set up.
Yeah, I think that was just visualizing some of the
Particles bouncing around in a box. But it's computing the motion of every particle at every moment, and it knows where the walls of the box are, and it bounces them off in some appropriate way.
So I have colleagues in economics who made the jump, who sort of do everything in LaTeX and in R together, and they'll write the grocery list. And yet, I'm sort of thinking about the mentality, well, my mentality and the mentality of students who've sort of gone through high school and write in Word, or maybe it's a Google, where all of this action is behind the curtain. trying to convert them to, you know, writing their Spanish term paper in this, or are you creating an environment in which people can go back and forth, do something in their notebook, take something out of it, and put it into their, you know, Word or Pages document that they're going to turn in? I'm not sure if I'm articulating my question well, but so much of, in my teaching, the things that are tripping up students are often not the concepts in economics, but how they get the dang table formatted in Word or whatever it might be, or how they take the diagram that they drew on a piece of paper and say, well, now how am I going to get this integrated with the way I've learned to express myself, whether it's in PowerPoint or Word or Pages, or, you know, trying to mesh those two worlds together. It almost seems to me, I know you're not, but it almost seems to me you're asking me to go to them to go to a different world from the one that they have been in before.
Mm-hmm. I guess we are to some degree. You might do more of the interfacing with it.
Well, I mean, you could spend a lot of time in and out of the classroom wrestling with all of that stuff. And from my point of view, that's, I mean, those are problems, but they're not necessarily pedagogical problems. And if you get bogged down in that, then you end up teaching them HTML or something, and that might not be appropriate in any course. It might be skills that they need, perhaps, depending on where they go, but it might not be something that we should focus on. So, and we've talked a little bit about this because there's very much in physics, especially the idea that you want to be able to take this and run it on your own computer. There's that sense. And I think by not dealing with that, I think there's a time for that, those skills. You learn them in the lab. You're going to work with a professor and you're going to learn some of that. In the classroom, I am completely happy not wrestling with any of that. There's nothing to install. Yes, those are good skills, and you probably need those if you're going to go to grad school in physics or grad school in anything. You need to be able to download and be able to produce pictures that go into a PowerPoint. But I think for a lot of what we do, in at least what I would advocate, is let's focus on the issues that we're trying to teach. And oh, by the way, if you press shift this, then you get a screen capture, and okay, now go to the Lilac, and they can help you move that screen capture into whatever you want.
Got it. So are you agnostic in your CSEM in terms of how people turn papers in?
Oh, that was an experiment, and I learned a lot of valuable lessons. Failure in science, it learns a lot, can teach you a lot.
Okay.
I would not consider that particular experiment something that I would want to do again. I would want to do it again differently.
Yeah.
So that was really hard for students that are used to working in Word to then come to here and try to type. It was just so frustrating. But I think there's a gem of an idea there that there should be a system that is really easy to use and can help them integrate data. So so I did not encourage anybody, although I must admit a lot of students in that ESEM ended up going on into computing. So
one thing I would add is that if you are comfortable with both Word and these notebooks, then transferring information from one to the other is not that difficult.
Okay.
That's true.
So here's the one line of code that you need to embed that image into the notebook. And as Doug showed before, the cells where you enter text, it's basically plain text. I could copy and paste that into a Word document or go the other way. So they're not incompatible formats.
And you can also grab and paste the actual rendered text, and you'll actually get the bold and the italics up when you
that
paste
I've never done, actually. Learned something new every
And
day.
you can actually do fine change and replace the markdown with bold formatting in Word. That's an advanced word skill.
And there is search and replace capability within the notebooks.
It also strikes me that, with functionality here, you no longer need a separate lecture capture system. That in essence, if you're creating notebooks on the fly and you can, after class,
15 years. And when I finally went to this system and I was running my code at the same place, I realized I've got bugs in all my code, and by moving it to the system where I'm actually running the same thing that I'm presenting, I'm finally it's embarrassing to all the students that I've shown that for years, and
That's why the space shuttle blew up.
that's what.
Or they're probably like, why wouldn't this run?
There is a nice story about economics that is related to data and part of the motivation for the Jupyter project, and that's reproducibility. And so there have been some very harsh economic stories that come out in favor of particular ways of governments collecting and spending money, or not. And there were some spreadsheet bugs. And if that data had been reproducible, made available in, say, a notebook like this, those bugs would have been found by peer reviewers, I think, very quickly.
So is there a movement to have code like this in peer-reviewed journals?
Oh, yeah. And not only peer-reviewed journals, but newspapers as well. So BuzzFeed is one of the big users of this. Bloomberg News is a big supporter of this. So a lot of the data-based stories, so journalism, economic arguments, any kind of argument where you're trying to convince people. So it really has a lot of different uses, but in the liberal arts setting, we're taking a sliver of that.
And I assume it's not directly on topic, but you're following the students who've been exposed to these modules and seeing how it's affected their subsequent careers at Brunel?
Well, what we've done more systematically is pre and post surveys
Yeah.
of their attitudes and choices, and we just finished year 3, and I would say the first group that took the course, they already had pretty good attitudes and sense of belonging, so we didn't really see any statistical shifts. The second group we gave it to, the introductory physics students who worked with the model, there were a couple upticks that were significant, and that was nice. But again, they started pretty high, about feeling comfortable talking with the professor, about considering a computer science major. But of the over 24 questions and indicators, only 3 or 4 had any significant difference. So that's very interesting.
Our numbers are pretty small.
Yeah.
Well, so as we, I hope the physics department adopts and keeps this, let's say we have 8, 10, 12 years, 3 kind of cohorts that go through the 4-year program, and if we catch them when they're freshmen and when they leave as seniors, hopefully we will see some impact.
That actually was an interesting aspect. So I'm kind of a project manager on this grant and
Yes.
just help out with things. But in watching it sort of evolve, realizing that the way that grant structures work and the way that evaluation for something like this would have to work didn't really mesh very well, because if you take something that was a course, that was very easy to assess and sort of say, okay, well, what happened? What did we do? But then once you split that up and it's supposed to hit students at several points during the curriculum over 4 years, that's a way different data collection. And then for anyone that's looking at this as educational research, well, there's lots of other things that could be happening at the same time. It's not like the curriculum stands still, right? So you sort of, as you get more complex, lose the ability to pinpoint exactly what your causal factors are, which is always the...
Although I'd be interested in being able to compare the upticks in physics with some of the other sciences. So for instance, it occurs to me that biology, in fact, probably has a more diverse student population in the freshman year course in terms of math backgrounds, general science backgrounds, and perhaps is seen as a little more accessible for somebody who is a little less secure in her, science and quantitative skills. And I think that would be a fascinating comparison. To what extent is the intro physics major slightly more rarefied than something like the intro bio freshman?
Ella, you guys were discussing the TLI consultants. Yeah. We used two TLI consultants when Mark ran the course, and they helped us develop these, think about and pilot some of these inclusive teaching practices. And so they were very, one of the powers of partnering with student consultants is the alternative viewpoint they provide, not just observing the class. And they also did some one-on-one interviewing and assessments with students, so they got information that we might not have gotten because it was peer-to-peer assessment. So I think the two of them were very valuable to this project early on.
Yeah. Very thoughtful. I think made lots of good suggestions.
Yeah. And in some ways, all of our pedagogical grants in year one should have TLI consultants to help us develop the innovations we're working on. There's a Haverford student and a Berkeley student. Are they both
The
They're
Haverford
both.
student is, I think.
I think they are both.
The class was roughly half-half. There were, I think, 8 Haverford students and 9 other students.
So I guess I have a question that kind of have trouble forming it. I'm thinking more along the lines of, the flipped classroom and how you're already using some of that for this, but kind of taking it to another level, if you could use this as a sort of flipped level instruction. So if, like you gave, your completed notebook at the end of the semester to, like the first week or so of the next semester students, and kind of like, here's what we did, kind of, but also here's like a crash course into what we learned. I don't know how that would be useful, but I'm trying to think of like the longevity of a notebook, I guess, after the semester's over. Or like, does it kind of lose a lot because they're not the ones who are actively making the notebook and they're just reading it after the fact? If that makes any sense at all.
There is if you do a Google search on Jupyter notebooks, you'll find tens of thousands of them perhaps at this point, and some of them are really interesting reading in and of themselves. Those don't actually work very well in the classroom. So there's a famous artificial intelligence researcher that works for Google. He's in charge of Google search quality. And he also, as a hobby, likes to write these notebooks. His name is Norvig, and he writes these notebooks that are just wonderful ways of learning about computing and solving problems. But they don't work pedagogically.
Right.
So there definitely is this trade-off between those kind of notebooks that are sort of interesting to read, and there's one on climate change, a bunch on climate change. So I think there is.
One transference that does occur though is I have a sophomore student working in my research lab, and she got first exposed to the modules in that intro lab, and so she's continuing to use her notebook and the code she already wrote to help her write code for our project. So there's a way in which she's bringing her notebook into a different space.
That's true. There are a lot of students that continue to use their accounts long after the course is over. So that's a good sign.
This is connecting to maybe some of the inclusive teaching. One, it was a wiki actually that I saw someone doing this, but I thought it was a great idea, and it would certainly be adaptable for a notebook. Is a faculty member at the end of each time he taught a particular course, he had the students write up a little paragraph or something about what advice they would give to themselves had they started taking this course again, right? Or what surprised them, some sort of little reflective essay that was basically designed, as Helen was saying, so that the next folks that come in look at this and say, oh, someone wrote that, wow, I didn't really think I could do this, but hey, I did, or whatever the sort of, takeaways are. And I thought that was kind of a nice way of, and then I think he also asked them for permission to use their name
with the post so that the students in the future classes could go back and contact the student, you know, and say, hey, I heard you took Professor such and such's, you know, 101. Can you tell me about what you did or something like that? So it's a
Do you
way
have
of
copies of these?
That's right.
yeah.
There is a comedian that's going to be here on Friday night who I think might mention some of computing. She's a Bryn Mawr graduate. Apparently there's something going on Friday night. You know about that?
It's part of the voice series from the Provost office, I think. She's a, yeah.
Oh, the Voices series.
Yeah, I think it's just one.
Oh,
One voice.
Voice.
Voice as a
Voice
medium.
series.
Yeah, but yeah, I've read about it in that page that Alumnae has.
Interesting. Cool. Well, we are out of time, but thank you all.
Thanks for coming.
Thank you.
If you haven't already, we would really appreciate it if you'd sign in. There's a sign-in sheet on that little table next to the coffee, just so you
You
can
made me lose some math.
track our
I
attendance.
use it there.
Yes. I bet 0 faculty.
You could have checked